My toy is a pendulum swing. Pendulum movement swings in an angle from side to side. For example, a clock pendulum, or in my case, a swing. Physicists refer to the motion of pendulums in oscillations. One oscillation describes the full movement from one point and back, lifting the pendulum as high as possible to the right side. One oscillation would go from that point all the way to the back. The laws that govern pendulum motion lead to an important property. Physicists break up forces into a vertical and a horizontal component. In pendulum motion, three forces work directly on the pendulum: the mass, gravity, and the tension in the string. Mass and gravity both work vertically downward. Since the pendulum doesn't move up or down, the vertical string tension cancels out the mass and gravity. This shows the mass of a pendulum has no relevance to motion, but the horizontal string tension does. Newton's first law defines the velocity of objects in response to forces. The law states that if an object moves at a specific speed and in a straight line, it will continue to move at a speed and in a straight line as long as no other force acts upon it. This law shows that since my swing moves side to side and not up and down, it has no force acting upon it. Newton's second law defines force equals mass times acceleration. If the swing makes an angle theta with the vertical, then A equals G tan theta. This is based on the idea of pseudo force experienced by a body in an accelerated frame. When a body is in an accelerated frame, it feels acted upon by the force to its mass multiplied by the acceleration of a system. Newton's third law states that every reaction has an equal force. This law works with the first law, showing that although the mass and gravity cancel out the vertical component of the string tension vector, nothing cancels a horizontal component. This law shows that the force acting on a pendulum can cancel out each other. Physicists use Newton's first and third law to prove that the horizontal string tension moves the swing without regard to mass or gravity.